Hi, my name is Joo Kim, and I am a Liberty University student studying Industrial and System Engineering. Drainage operation is an infrastructure that is now a big part of every city, and it needs to be running continually. As an ISC student, I thought learning the process of infrastructure that affect people's daily life can be a good motivation. And here I brought a previous study done on Edmonton City's drainage operation. The study was done in early 2000 when the city's drainage operation needed improvement and repairment due to its growing population size. A lot of money was invested because it can directly affect the city's environment. According to the efficiency report published by the Office of the Auditor, the drainage system of the city of Edmonton was very inefficient. Thus, decent amount of money was wasted due to its inefficiency. The service branch of the city, Office of the City Auditor, and engineers grouped up to improve the drainage operation with more modernized approaches. There are three main problems to the operation. The city's drainage operation needed to be visualized with a computer-based simulation, and based on the research, too much time was wasted during the non-value added work process because of the transportation or something unrelated to the process. And lastly, because some process could be done at any time, we needed to eliminate those processes from the main process line to improve the whole process. The goal of this study is to use the computer simulation to detect inefficiency and apply the lean concept to improve the productivity of the drainage operation. Here, I'll be focusing on the CBC, which is catch basin cleaning of one site. This is just a part of the entire process. This is the simul model of current CBC of one site. It has a running time of 100 hours and its source has an inter-arrival of 30 minutes. This inter-arrival time is just an assumed time. The actual inter-arrival time is shown differently. The model has 17 different servers. Each processing time is from the study. So what is happening here is when the truck comes from the previous process, the work crew assemble the vacuum pipe into the basin to vacuum the debris. And if there's any unvacuumed debris, the work crew clear out the debris manually so that the sewage can keep moving to the next process. In doing so, both value-added process and non-value-added process are required. Value-added process is composed of either operation steps or a combination of operation and inspection steps in which the basic work performed is valuable to the customer and advances the process. Non-value-added process steps are those steps that are not considered either an operation step or a combined operation and inspection step. Usually the problem with the value-added process is that it can cause waste of time. Mostly it's due to the transportation or work crew's unrelated works. However, it is hard to adjust many changes to this model, since the model is too saturated and complicated. We can only adjust the parking time. And the Mark CV is a process that can be done by any crew at any time, so it can be eliminated from the process line. So here we have modified version of CBC of one site. The processing time of part truck has been reduced, assuming that the personal training has been done to the work crew. And the Mark CB is off from the service line because it can be done at any time. So after I made the current and modified simul model, I ran experiments with 10 replication for each models to come up with the throughput numbers. And based on the results, I was able to tell that the modified CBC model has 3.4% improvement on its productivity. There are quite a few limitations to this study. One of the most noticeable one is that they didn't spend enough time on collecting actual data from daily work. So, so a lot of number in simulation model was assumed based on the probability. Thus, modified version of CBC model needs more experimental implementation. Through the project, the drainage operation system of the city of Edmonton was visualized using Simio. By applying the Lin theory to the study, some of the processes were shortened or eliminated. Based on the simulation model, the modified CBC model showed improvement of 3.4%. However, because this is just a laboratory experiment, more research needs to be done to come up with more accurate model.